Hi, my dear students. Good morning to all. Welcome back to Maths Online class. So, we are moving on to the last of the chapter, Exponents and Power. Before going to the last concept of the chapter, there are some more problems from the exercise 13.2. So, today we will finish the exercise 13.2, that is problems related with the laws of exponents. Then we can discuss the last concept of the chapter. Solve the questions from exercise 13.2. Question number 4. Express each of the following as a product of prime factors only in exponential form. That means the first question is 108 into 192. This we have to express as exponential form by finding out the prime factors only. So how we will find out the prime factors of a number? You know that, isn't it? We have studied the prime factorization method. So the given two numbers we are first prime factorizing. That is 108 and 192 are the given two numbers that we are prime factorizing. So first 108 prime factorizing. What is it? You know 108 is a even number. So we can start with 2. So 108 dividing with 2 you will get 54. Now again it's an even number. Again you can prime factorize with using 2. Then 2 in 24, 27 times. Now 27 is not an even number and it's a multiple of 3. So we can use 3 here. So 3 into 9 is 27. Again 9 is a multiple of 3. So 3 is a factor. So 3 into 3, 9. Then 3 is a prime number. So the only factor is 3. So we have to use here the numbers only prime numbers. That is the question. So we prime factor is 108. What is that? 2 into 2 into 3 into 3 into 3. So first number is over. Now second number 192. Again it's an even number. So starting with 2 in 192 96. Again it's an even number going with 2. You will get 48. It's an even number again 2. 24. Again 2. 12. 2. Then 6. 2. 3. 3 is a prime number. So the only factor is 3 itself. So we prime factor is 192 also. Now the question first part is over. We have prime factors, the numbers. Now the second part is we have to express this as exponential movements, writing as something raised to power. So we have got here the factors. Now let us count the factors. Now 108 we can write it as 2 into 2 into 3 into 3 into 3, or in other words how many 2's are there? 2 multiplying 2 times. So 108 we can write 2 raised to 2 square. Then 1, 2, 3. 3 3's are there in 108. So 3 cube. In 192, how many 2's are there? 1, 2, 3, 4, 5, 6. So 2 raised to 6. And only 1, 3. So 3 or 3 raised to 1. Now we can apply the law. What laws we can apply here? So we are expressing 108 as 2 cube into 3, 2 square into 3 cube, and 192 as 2 raised to 6 into 3 raised to 1. Now I am writing first the numbers with same base, that is 2 square and 2 raised to 6, that I wrote similar in the same. Then 3 cube and 3 raised to 1. Now we can apply the law, that is multiplying the exponents with same base. Here we have same base 2 itself, isn't it? So what is the law? A raised to m into a raised to n is a raised to m plus n. So applying that law, 2 raised to 2 plus 6 you will get this one. Similar way here we will get 3 raised to 3 plus 1. So what is the law we here used here? A raised to m into a raised to n is equal to a raised to m plus n. Now adding 2 plus 6 you will get 2 raised to 8. 3 plus 1 you will get 3 raised to 4. So 108 into 192 can be expressed in the exponential form 2 raised to 8 into 3 raised to 4. So this is the way you have to express. In question 270. So first we have to prime factorize the number. So prime factorizing 270, if you are starting with 3 that is also correct, but here 270 is an even number, so I started with 2. 2 in 270 when dividing 135. If you don't know to divide like this, you can do the common division method in your working column and write the quotient over here. Don't make mistake. While you're dividing, make sure that when you're dividing, you're getting remainder 0. Then only you can write the quotient here. If you're getting remainder any number, then that number is not divisible. Here you can apply the divisibility rules, which number can be used. If you're getting an even number, you can start with what? 2 and all. And if a number is ending with 5 and all, the easy method is go for 5. So here I know the factors, that's why I divided with 3. So 135 and divided with 3, I got 45. Again 45 and divided with 3 I got 15. Again 15 divided with 3 I got 5. Then 5 in 5. 5 is a prime number, so we can divide it only with 5. So 5 in 5, 1. So this is the prime factorization of 270. What is it? 2 into 3 into 3 into 3 into 5. Now we can write the exponential form. What is it? How many 2's are there? 2 only 1. So 2 raised to 1 into 3. How many? 1, 2, 3. So 3 cube into 5 also only 1. So 5 raised to the power 1. Now here we can apply the law multiplying with same exponents. So that means 2 and 5 are having here same exponents. So I grouped it first. 2 into 5. What is its power? Raised to 1. So I gave whole brackets because its power is same. Now 3, its power is 3 itself. So I wrote it differently, 3 cube. 2 into 5 is what? 10. 10 to the power 1 is 10 itself. Then 3 cube, you can write it in the same way itself. So 10 into 3 raised to cube. This is the exponential form of 270. Example of this type, 729 into 64. So we have to write it in the exponential form. So first prime factorizing the number 729. This is not an even number, so we cannot use 2. Now checking the divisibility of 3. 7 plus 2, 9. 9 plus 9 is 18. 18 is a multiple of 3. That is how you are checking the divisibility rule, isn't it? So you can apply the divisibility rule for knowing which number is divisible. So we can start with 3. So 3 in 729, 243. That is 243. Again we are checking the divisibility rule. 4 plus 2, 6. 6 plus 3, 9. 9 is a multiple of 3. So I can use 3 here. Now again in 24, 8, 3, 1. So 81. Again 8 plus 1 is 9. So 3 we can use here. So 3 into 81, 27. Now 27, you know it's a multiple of 3. So 3 into 9 is 27. Again 9, 3. So 3 into 3 is 9. 3 is a prime number using 3 itself. So 3 in 3, 1. So we prime factorize 729. Next 64. You know 64 is an even number. So I can start with 2. 2 in 64, 32 first. Then again going with 2, 16. 16 going with 2, 8. Then 2, 4. 4 in 2 in 4, how many times 2? Again 2. 2 itself because it's a prime number. So prime factor is 729 and 64. Now writing down the factors. How many? In 729, how many 3's are there? 1, 2, 3, 4, 5, 6. So 3 raised to 6. Now in 64, 1, 2, 3, 4, 5, 6. 2 raised to 6. Here there is no need of applying any. Yeah, we can apply. 3 raised to 6 into 2 raised to 6. Here the powers are same, isn't it? So which rule we can apply here? Yes, multiplying with same exponents. So 3 raised to 6 into 2 raised to 6 can be written as, that is 3 into 2 whole raised to 6. That is what 3 into 2 is 6. So you will get 6 raised to 6. Or if you are stopping by here also, no problem, because the question is you have to write in the exponential form. They didn't ask you to apply the laws and all. So if you stop it by here also, it's next we can solve in another set of questions. That is simplify. 2 raised to 5 whole square into 7 cube divided by 8 cube into 7. So we are going to solve it using the laws of exponents. Whatever laws you have studied, using that we are solving this. So here first 2 raised to 5 whole square. Here we are taking the power of a power. So what is the law there? A raised to m whole raised to n is what? A raised to m into n. So first we are applying the law here. So 2 raised to 5 into 2 into 7 cube I wrote it same. Now 8 cube. Now this 8 I am going to represent as 8 is 2 cube, isn't it? 8 when we are prime factorizing. How can we prime factorize 8? You know, when we prime factorize 8, we are getting 2 into 2 into 2. That is 2 raised to cube. So instead of 8, I wrote 2 cube. Then already one power is there for 8, isn't it? What is that cube? So that whole cube into 7. So again, we are having a power of a power. What is that? 2 cube whole raised to cube. Then applying the law there also, we will get 2 raised to 3 into 3. What is 2 raised to 3 into 3? 2 raised to 9. Now we have 2 raised to 10 into 7 cube by 2 raised to 9 into 7. Now we have here what? Same. We have exponents with same base. So, and we are dividing here. So, we are applying that law. So, that is 2 raised to 10 divided by 2 raised to 9. We will have 2 raised to 10 minus 9. Again, 7 cube divided by 7. That is 7 raised to 3 minus 1. So, we applied the rule dividing the exponents with same base. Now 2 raised to 10 minus 9 is 1 itself. So 2 raised to 1. Then 7 raised to 3 minus 1 is 7 square. Now here they didn't ask you to write it in the exponential form. They just ask you to simplify and we can multiply. So 2 into 7 square is 49. So 2 into 49, 98. So in this way you have to simplify. For example, 25 into 5 square into t raised to 8 divided by 10 cube into t raised to 4. So first 25 you can write it as 5 into 5, that is 5 square, into again you are having one more 5 square into t raised to 8 I wrote same. Then 10 cube, here 10 cube I wrote it as 10, you can write it as 5 into 2. So 5 into 2, then 1 cube is there for 3, isn't it? So 3 I wrote like, then 10 raised to 4. Now 5 square and 5 square, so multiplying with same base. So 5 raised to 4, 2 plus 2 you will get 5 raised to 4. Again t raised to 8 I wrote same. Here I am going to split it. 5 into 2 whole cube is 5 cube into 2 cube. Now I am taking 5 raised to 4 and 5 cube others. So that is 5 raised to 4 divided by 5 cube, you will have 5 raised to 4 minus 3. Here t raised to 8 and t raised to 4. So t raised to 8 minus 4. 2 cube I wrote it same, no difference. 2 cube means what? 2 into 2 into 2, that is 8. Here there is nothing to cancel in 2 cube, because in numerator we don't have any 2 terms. So I wrote it in the same way. Now 4 minus 3. 5 raised to 4 minus 3 you will get 5. T raised to 8 minus 4 you will get t raised to 4 and 8. Here there is nothing more to simplify because we don't know the value of t. So what is the answer? 5 t raised to 4 by 8. So when you have common exponents with same base, you have to apply the laws. So using the laws you can simplify and write in the simplest form. So winding up today's class, today we discussed the exercise 13.2 and we have completed that exercise. Copy down the notes given and attach the test paper. We'll meet with the next concept of this chapter in the next video.